You've probably had this happen. You're talking to an AI chatbot and it just forgets. It's frustrating. But what's the secret to building an AI that can actually remember, reason, and even use tools? Well, today, we're going to go beyond the basic prompt and see how developers are building the next generation of truly smart AI. Right? You're in the middle of a great conversation, you think you're finally getting somewhere, and then you ask it to recall a simple thing you mentioned just a minute ago, and nothing. You get that digital blank stare. It's a super common experience, and believe me, there's a very specific reason for it. This picture just sums it up perfectly. The user asks, "What is my name?" And the AI says, "I'm sorry, but as a language model, I don't have the ability to know personal information." It has absolutely no memory of the conversation, even if you told it your name 2 seconds before. So, what's really going on under the hood? Well, the heart of the issue is this. Large language models, or LLMs, are what we call stateless. All that means is that every single prompt you send is treated like a brand new, isolated event. The model has no built-in memory of what you just said. But what if we could give it one? Let's take a look at how that's done. To build these smarter AIs, we have to move way beyond that single, simple prompt. So let's start with a foundational technique that kind of lays the groundwork for everything else we're going to talk about. Okay, before we build our super smart AI, we have to make sure it can actually run without, needing a supercomputer. These models can be huge. So one key trick to shrink them is called quantization. The analogy here is perfect. Think of a clock. If you only care about the hour and the minute, you can just get rid of the seconds hand. Sure, it's a little less precise, but it's way simpler. Quantization does the exact same thing for AI, trading a tiny, tiny bit of precision for a massive boost in speed. And this slide just visualizes that trade-off perfectly. See the top line? Representing pi with 32 bits gives you all that beautiful precision. But when we quantize it down to 16 bits like you see on the bottom, we lose a few decimal places. That tiny loss in accuracy makes the models so much smaller and faster. And that's absolutely crucial for building these more complex applications. So our model is now lean and efficient. Great. But how do we get it to do more than just answer one question at a time? What if a task needs multiple steps? Well, this is where we need to build a kind of AI assembly line. This is the baseline, right? The world we're all used to. You give the model one input, like, what's the capital of France? And it gives you one output, Paris. It's a single, self-contained transaction. But what if our task is way more complicated than that? The solution is to create what are called chains. Instead of trying to cram everything into one huge prompt, we break the task into smaller logical steps. Take a look at this diagram. First, a prompt comes up with a story title. The output of that, the title, becomes the input for the next prompt, which then creates a character. Then all of that gets fed into the final prompt to actually write the story. It's literally an assembly line for thinking. Now, this idea of chaining things together, it's the key to solving our original problem, the forgetful AI. Now that we have this assembly line, we can add one of the most important components to it, a memory. And wow, this slide just shows the night and day difference. On the left side, without memory, the user says their name, asks what it was, and the AI has no clue. Now look at the right, with memory. Just by feeding the conversation history back in, the AI remembers, and suddenly you can have a real conversation. So the most straightforward way to pull this off is with what's called a conversation buffer, and it's pretty much what it sounds like. Every time you ask a new question, the system automatically stuffs the entire conversation history right back into the prompt. It's simple, but it works. But there's a more elegant solution, and that's conversation summary memory. Instead of sending the whole chat history every single time, which can get really long and slow, we use a second LLM. Its only job is to read the ongoing conversation and create a quick, concise summary. That little summary is then passed along as context, saving a ton of time and tokens. So which one is better? Well, this table breaks down the trade-offs really nicely. The buffer method is super easy and you don't lose any information. But as the chat gets longer, it gets slow and expensive. The summary method, on the other hand, is great for really long conversations. But, it does need that extra call to another AI, and you always risk losing some subtle details in the summary. It's all about picking the right tool for the job. Okay, now we get to the really, really exciting part. We've given the AI a workflow, we've given it a memory, but what if we could give it tools? What if it could actually interact with the outside world? That's where agents come in. This is such a fantastic example. On its own, an LLM is actually terrible at precise math. It might just make up an answer to 47 divided by 12 times 3.14. But when we build an agent and give it access to a simple calculator tool, it knows to use the tool and bam, it gets the right answer every single time. So what exactly is an agent? Well, it's an LLM that's been beefed up to do more than just talk. It can reason about a problem. It can choose which tool to use, like a calculator or a Google search. It can plan out a whole sequence of actions to reach a goal. And it can even realize when it's made a mistake and correct itself. It's a game changer. And the magic behind this is a framework called REACT, which stands for Reason and Act. It's this simple but incredibly powerful loop. First, in step 1, the agent has a thought. It basically reasons about the problem. Then, step 2, it takes an action, like using one of its tools. And finally, step 3, it makes an observation based on the result, which then feeds right back into its next thought. It's a constant cycle of thinking and doing. And here we can see that whole React loop in action. The prompt asks for a price in euros. So let's follow cycle 1. The agent's thought is, okay, I should probably search the web for this. Its action is to use Google to find the price. Its observation is that the price is $1,299 US. That's not the final answer, so it kicks off cycle 2. The thought is now, aha, I need to use a calculator for the conversion. The action is to do the math, and the final observation is the correct price in euros. It's a two-step reasoning process, all made possible by giving it tools. So we've covered chains, memory, and agents with tools. Now let's put it all together and see the big picture of how a modern, smart AI application is really built. The most important point is that these aren't just separate, isolated tricks. They are modular building blocks. Frameworks like LangChain let developers just snap these components together, the models, the memory, the agents, to create a complete, intelligent system that's so much more capable than a simple LLM on its own. So to sum it all up, chains let us create those multi-step workflows. Memory provides the crucial context from past conversations, fixing that whole forgetfulness problem. And agents use tools to reason about and interact with the real world, finally breaking out of their digital box. And this brings us to a final, pretty fascinating question. Now that you know how these smarter systems are actually built, with memory and workflows and tools to access the real world, what's the first thing you would ask them to do? What big, complex problem would you want an AI like this to solve for you?